Okay, guys, here we are, back again. Finding complex zeros is the next topic. We already talked about complex numbers. I think you guys are good with that. If not, please send me questions through Google or WhatsApp. All right, so now we're solving this quadratic. And we're going to express the complex zeros in standard form. Remember, standard form is a plus bi, right? And this is not factorable, so I have to use the quadratic formula, which is negative b plus or minus b squared minus 4ac over 2a, okay? So, right, my a is 6, b is 12, c is 7. So I'm going to substitute all my values in to my formula. Negative 12 plus or minus square root of 144, which is the 12 squared, minus 4 times 6 times 7, all over 2 times 6. Okay, we're going to simplify that. Negative 12 plus or minus square root of 144 minus 168 over 12. And then we're going to get negative 12 plus or minus square root of negative 24 over 12. I can simplify the square root of negative 24 to 2i radical 6. And then finally I can simplify my answer to become negative 1 plus or minus I radical 6 over 6. So this is in the correct form, a plus bi, so my a is here, which is negative 1, and my b is radical 6 over 6. Okay, so those are my two complex solutions because they have I in them. All right, moving on to the next one. I already talked about that when I went over number 7. So again, you have to take 92 and divide it by 4 and look to see what the remainder is. So 4 goes into 92 23 times evenly with no remainder. So then I know that, if you remember, I is equal to I squared is negative 1, I cubed is equal to negative I, and I to the 4th is equal to positive 1. So then this is going to give me a positive 1 because there's 0 remainder, right? Remainder 0, which is this option here. And here, 109 divided by 4, I'm trying to find the remainder. So that goes in 27 times with a remainder of 1. So it goes in 27, remainder of 1. Remainder of 1 would be I to the 1st, so that means it's equal to I. Okay? Let's see. Okay, we're moving on to the next slide. All right, so these are just examples of complex zeros that are already factored. Again, we talked about multiplicity when we were dealing with real zeros. So if a zero of a polynomial function and a corresponding factor, x minus a, occurs exactly m times in the factorization, then we say it has a multiplicity, that it has a 0 of multiplicity m, right? So in this case, I have a 0 at x equals 3, but it's a multiplicity of 3. Here I have a 0 at x equals 2, multiplicity of 1. And then we know that imaginary solutions occur in pairs, right? It's always plus and minus. So one of my zeros here would be x equals plus or minus 2i, okay? And here too, this is already in factored form, the second one. So I have x to the 4th, so x equals 0 is a solution with a multiplicity of 4, x equals negative 2 is a solution with multiplicity 3, and then I also have x equals plus or minus 3i as solutions as well with multiplicity 2, okay? Here, it says find all the zeros of polynomial and then give the complete factorization. So, there's one of two ways I could solve this. I could just move the 25 to the other side as a negative, take the square root, which is going to give me this, right? And then we know that's going to give me plus or minus 5i, right? So those would be my zeros, and then the factors then would be x plus 5i and x minus 5i. If you actually do distributive property, you will see that you get back x squared plus 25. Because remember, I times I is I squared, and that's negative 1. And I'm going to end up multiplying a negative times a negative, which gives me the positive 25. So these are my zeros. This is the factorization. Okay? Here, this is not as easily solvable, so we're going to have to use a quadratic formula. Again, A is 1, B is 2, and C is 2. So I'm going to have negative 2 plus or minus the square root of 4 minus 4 times 1 times 2 all over 2. So then that's going to give me negative 2 plus or minus square root of 4 minus 8 over 2. That simplifies to negative 2 plus or minus square root of negative 4 over 2, which is negative 2 plus or minus 2i over 2. And finally, I can simplify that to 1 plus or minus I. So my zeros are 1 plus or minus I. Whoop, let me write that a little bit better. 1 plus or minus I. But my factors, because remember, factors have to be written in the form x minus a, where a is a 0, right? So my zeros are 1 plus I. So I have to do x minus 1 plus I. And then my other one is x minus 1 minus I. So if you think about it, you're really subtracting. So then this is just going to become x minus 1 minus I, and this is going to become x minus 1 plus I, which are just the opposites of what I had before. So these are my factors, okay? Here I have 4 terms, so I have to factor by grouping. So I'm going to group the first 2 and the last 2. There's a GCF here of x squared I can take out. That's going to leave me with x plus 1. Here I could take out 9, which leaves me with x plus 1. So my factors are x plus 1 and x squared plus 9. So my question is, can I factor x squared plus 9? I know you're used to factoring x squared minus 9 into x plus 3 and x minus 3, but now I have a plus sign here, not a minus right here. So when I have that situation, that tells me that it's going to be imaginary roots. So I can factor that into x plus 3i and x minus 3i. Okay, if you look at that, x plus 3i and x minus 3i, that's x squared, right? The middle terms are going to cancel out, and then I get negative 9i squared. The I squared, remember, is equal to negative 1, so negative 9 times negative 1 is positive 9. That's how I get that. So anytime you have a situation, like for example, if I had x squared plus 25, since 25 is a perfect square, I know it's going to be x plus 5i and x minus 5i. That's just an example, right? So it's cubic. I have my 3 factors, so my zeros are x equals negative 1 and plus or minus 3i, okay? Here I can factor out x cubed. That's going to leave me with x squared plus 7. And this is, although this is not a perfect square, I can write that by, I can simplify that by making it, taking the square root. It just doesn't look as nice. So I can factor it into x plus I radical 7 and x minus I radical 7. So the only difference is if this was a 9, I would have 3i here and 3i here. But since 7 doesn't have a perfect square root, I'm just going to leave it as square root of 7. So I have my factors and my zeros are x equals 0 and x equals plus or minus I radical 7. Okay? Here, this is interesting because you see I have a 4th degree and then I have a square here. So I think we talked about this before, that I can factor it with x squared and x squared, right? And I need 2 numbers to multiply to give me negative 4, but add to give me 3. So that's going to give me positive 4 and negative 1. So if I were to multiply these out, you will get this back again. So you're factoring this just like you would if this was an x squared here and this was an x to the first. It's the same way. It's just that instead of x and x, I have x squared and x squared, right? I can factor this further. This x squared plus 4 is just like the x squared plus 9 we looked at on the previous slide that we factored into x plus 3i and x minus 3i. So then this must factor into x plus 2i and x minus 2i. The x squared plus 1 is easy. That's x plus 1 and x minus 1. I should have 4 factors, and I do. So those are my factors, and my zeros are x equals plus or minus 1 and plus or minus 2i. Okay, I'm going to stop here because this one's going to be a little bit more interesting, and I want you to review the video, and I will probably post a couple questions for you to do. Bye.